Mr. Munyon here again with activity 15-1. We're going to be focusing on kites and triangle midsegments. Alright, so in activity 15, obviously we're going to develop the properties of kites as well as the triangle midsegment theorem. So exactly what the title says we're going to do. Mr. Cortez here is the owner of a tile store and wants to create a database of all the tiles he sells in the store. Mr. Cortez begins by exploring the convex quadrilateral. The term quadrilateral is going to be abbreviated as quad for the majority of this activity 15.1 through 15.4. All right, so here it says given quad GEOM, list all the pair of opposite sides. So opposite obviously means the sides that are not touching each other, not right next to each other. The ones that are touching, like GE right here and EO, those are considered either consecutive or adjacent. So let's identify all the ones that are opposite of each other. So GE and MO. It's an easy one there. GM and EO. Okay, those are some segments that are opposite of each other. What about the pairs of consecutive sides? So consecutive sides, as I just mentioned, would be that are right beside each other. So GM is next to GE. The other way, we could say GM is consecutive to MO. We could also say MO is consecutive to OE. And OE is consecutive to GE. Right, so obviously the pairs, the sides that are touching each other are considered consecutive. What about the opposite angles? So opposite angles would be the angles that aren't touching. So this leg is shared by angle G and angle E. Those are consecutive angles, so the opposite angles would be the ones that are not sharing a side on there. So this angle and this angle here are opposite, so angle G and O. Whoops, I guess I should put it as an angle. Or we could say angle M and angle E are opposite of each other. I guess we can probably use this figure down here for the rest of these. It says list the pairs of consecutive angles. All right, last thing is draw the diagonals and list them. So the definition of a diagonal is a segment that connects to non-adjacent vertices. So if I connected adjacent vertices like M and O, that's just a side of the kite. But if I connect it to a non-adjacent vertice, so like M connected to E, that is a diagonal of the kite. Or if I connect G to O, so GO is a diagonal and ME is a diagonal, and now we're pumping ourselves up because it says go me. All right, moving on. Now that we have identified the consecutive and adjacent or consecutive or opposite sides angles, and we've identified the diagonals, let's explore the properties. So hopefully you guys already know, but if not, the definition of a kite here says it's a quadrilateral, a four-sided polygon, with exactly two distinct pairs of congruent consecutive sides. So what that means is I have a pair of congruent consecutive sides. So like I can see this piece here, it's consecutive and congruent to this one. And the two distinct parts means that this pair of consecutive sides here is a different length than the other pair of consecutive sides. So that's what it means by two distinct pairs of consecutive congruent sides. So given we have quadrilateral KITE, and KI is congruent to KE. We already labeled those with our little tick marks there to show they're congruent. IT is congruent to ET. Got that part labeled on there as well. It says one of the diagonals divides the kite into two congruent triangles. So if I was to draw a diagonal here, one of them would divide it into two congruent triangles. So I see here that if I draw this one, the top and the bottom look like a reflection of the exact same triangle. So draw this diagonal and list the two congruent triangles. So triangle KIT is congruent to triangle KET. Explain how we know they're congruent. So other than just looking like they're congruent, they both have a pair of sides with one tick mark, two tick marks, and then they share the side in the middle. So that means there's side, side, side congruency. Hopefully we learned about this in activity 11. All right. For the next part of this one, it says draw the other diagonal. Explain how we know the diagonals are perpendicular, or that this diagonal is perpendicular. So if I draw the other diagonal here, how do I know that this diagonal is perpendicular to the red one, other than just saying that it looks like it is? Well, if these are congruent triangles and KT is a line of reflection, one of the properties that we learned about during a reflection is that points and segments get reflected perpendicularly across the line of reflection. So that means this point here, to get reflected across and be the congruent shape to get reflected to point E, has to go perpendicularly across the line of reflection. So how do we know that the diagonals are perpendicular? Definition of if one is a line of reflection, then being reflected, that point has to be perpendicularly reflected across. All right. Complete the following list of properties of a kite. Think about the angles of a kite as well as the segments. So 3 of them were already listed here. Exactly 2 pairs of consecutive sides are congruent. That's the definition. The next one says one diagonal divides the kite into 2 congruent triangles. We already did that property, and the diagonals of a kite are perpendicular. Already talked about that one. 3 that were not mentioned. The other diagonal divides the kite into 2 isosceles triangles. So not only is this green diagonal here perpendicular to the red one, but notice on the left side you have an isosceles triangle because KI is congruent to KE. On the right side, you have a different isosceles triangle because IT is congruent to ET. So you do have 2 different isosceles triangles on there. So one, the red diagonal, makes 2 congruent triangles. The green diagonal makes 2 different isosceles triangles. All right, number 5 says that one pair of opposite angles are congruent. So notice angle K and T are not congruent, because if you put T way out here, that'd be a really tiny acute angle, and if you have K, it almost looks like it's 90 degrees. So opposite angles K and T are not congruent, but because angle I and E are a reflection of each other, they have to be congruent. So that line of reflection makes those angles I and E congruent to each other. Last one, number 6, one diagonal bisects a pair of opposite angles. So notice the red diagonal here being a line of reflection. Whatever this angle is here gets reflected across. So that means that the whole angle K was bisected into 2 congruent angles. And then down here we also have a pair of congruent angles because that was bisected as well. So that line of reflection cuts through the angles as well. So each angle gets reflected across. Meaning they're congruent means the whole angle K and T have to be bisected. All right, moving down to number 3, it says Mr. Cortez says the diagonals of a kite bisect each other. Is Mr. Cortez correct? So notice the red diagonal does bisect the green one. This right here is definitely going to be, I'm going to erase some of these. All right, because it's a line of reflection, the distance from the intersection to I and the distance from the intersection to E is going to be congruent. So the green one was bisected by the red one. However, I can tell just by looking that from K to the intersection and from the intersection to T is not the same. And if I move T out here, it's definitely, the farther I get it, the longer that segment's going to be, whereas K doesn't have to move. So they don't bisect each other, only one of them is bisected. So only one is bisected. And we could say by the line of reflection, right? Let's check our understanding of what we know about a kite. Why is a square not considered a kite? Okay, well, what's the definition of a square? Quadrilateral with 4 congruent sides and 4 right angles. What's the definition of a kite? A quadrilateral with 2 pairs of distinct congruent sides, consecutive congruent sides. So that's the big difference, is that although a square has 2 pairs of consecutive congruent sides, like this side is congruent to this one, and then the next 2 sides, this one is congruent to this one. The big difference is that it has to be distinct pairs, so that this piece here is not congruent. So although the picture looks like a square based on what I have labeled, I know this to be a kite because these two are different than this one. So the big difference between a square and a kite is a kite has distinct or different pairs of consecutive congruent angles. All right, I'm going to erase. Oh, wait, we actually have a little bit of number 5 over here on the side. So it says, suppose AC and BD are the diagonals of a kite. What is the formula for the area of the kite in terms of the diagonals? So on your formula chart, you'll notice you actually don't have a formula for kites on there, but there is one for a rhombus, and it happens to be the exact same thing. So your area equals 1/2 D1 times D2. And I actually went ahead and put, if you want to pause the video here and copy it down a little bit, where this formula comes from. If you think of a kite as 2 congruent triangles where, you know, this distance here is D1, if the total distance of the diagonal was broken down, you could use it as like a base and a height of a triangle. So I just added the area of 2 triangles together, simplified, and you end up 1/2 D1 times D2. So there's the work shown of where it comes from, or if we, you know, just need to use it later on, find the area of a kite, we've got that as well. All right. Moving on, we now need to focus on midsegment of a triangle. So the segment whose endpoints are the midpoints of 2 sides of a triangle is a midsegment. So whenever you have a segment, like MN right here, that each endpoint is the midpoint of a side of a triangle, so M is right in the middle here, and N is right in the middle of that side. That means that MN is a midsegment. And once we've identified a midsegment, 2 properties are true based on the triangle midsegment theorem. So if we have a midsegment of a triangle, a segment that connects 2 midpoints on sides of a triangle, then this property is true here. The midsegment of a triangle is parallel to the third side. So this piece here is parallel to the third side, the one that didn't have a midpoint used. And its length is 1/2 of the third side. So whatever MN is, it's going to be half of whatever AC is. So this distance here is going to be half as much as the total distance for AC. All right. So let's, we're going to do a little bit on this one. We're going to skip some, and we're going to do a little bit just so we can actually get to the practice here. So let's say complete the hypothesis and conclusion of the triangle midsegment theorem. Hypothesis: M is the midpoint of AB. N is the midpoint of BC. Then MN is parallel to AC. And MN is 1/2 of AC. Okay, it says find the coordinates. We're not actually going to do, this is the part that I'm going to skip. You can find the coordinates of the midpoint by doing the formula right here. We also have the slope formula right here. But we're not going to do it with general A's, B's, C's, and D's. You could if you want to, but we're going to get more practice with actual numbers, making sure we know how to do this. So let's skip this section here and jump now to check your understanding question 7. All right. Number 7 says, are the midsegments of an isosceles triangle congruent? Explain. So here I've gone ahead and drawn, I have an isosceles triangle, and the midpoint here, here, and here. If I draw these and connect, this is a midpoint here. So this is a midpoint here. That is a midsegment I just drew. If I connect these 2 midpoints, that is a mid-segment. And if I connect these two midpoints, that is a mid-segment. So there's 3 different mid-segments on this isosceles triangle. Are the mid-segments of an isosceles triangle congruent? Well, I can tell just by looking that this one here, the horizontal one here, is definitely shorter than the other 2. However, if 2 of the sides are congruent on an isosceles triangle, and each of these mid-segments going down towards the bottom here are 1/2 of that, these 2 pieces have to be congruent. And notice when you find the midpoint, I put 1 tick mark on here because when you find the midpoint and cut that in half, each half of the original side length is going to be the exact same as your new mid-segment. I guess this would be the mid-segment here. So when I'm looking, let me make it a different color here. This distance here, because it was the whole side cut in half, is going to be equal to this mid-segment here because that's half of the total distance as well. All right, for question 8, let's do this problem. It says given DE is parallel to AC, so DE is parallel to AC. Is DE a midsegment of the triangle? Well, it looks like it, but what is the definition of a midsegment? A midsegment connects 2 midpoints. So it looks like it starts at D, ends at E. Is D a midpoint? Well, this side is 6, this side is 5. That's not a midpoint, and this is not a midpoint. So although the picture looks a lot like a midsegment, D and E are not midpoints, so it doesn't meet the definition of a triangle midsegment. So no, point D and E are not midpoints. Number 8, we just finished, so let's now look at number 9. It says here we have triangle PQR on the diagram with midsegments AB and CB. So both of those conveniently already drawn for us. Verify the triangle midsegment theorem using coordinates of triangle PQR and midsegment AB. Okay, so I need to check to see that the AB right here, we're going to check the distance of these. And we're also going to check the slopes to see if they have parallel slopes, so if the slopes are the same. Okay, so let's go ahead and find the distances first to make sure that AB is 1/2 of RP. So AB equals, distance formula is change in x squared plus change in y squared. Looks like change in x is 3, change in y is 1. Equals 9 plus 1 is square root of 10. Okay, so for RP, I can do the same thing. So for RP, you have 2 and 1, 2, 3, 4, 5, 6. So change in x was 6. And change in y was 2. So looks to me like we get 36 plus 4. So 36 plus 4 is 40. And I could simplify this. I do know that if I wrote this as square root of 4 times square root of 10, oops. Square root of 4 is 2, so I get 2 times square root of 10, which is exactly twice as much as what I got before. So RP equals 2 root 10, or twice as much as what I got for AB. So, okay, definitely twice the length. For the slopes, I can find the slopes. I get rise of -1, run of 3. And for the slope of the other line, I get rise of -2, run of 6, which simplifies to 1/3. So I do get that the slopes are congruent, so the lines are parallel. So both of those distances prove that the midsegment is half of the third side, and the slopes prove that they are parallel to each other. All right, let's get some practice. If you haven't practice some on your own, now would be a great time to do questions 10, 11, and 12. Pause the video, and when we get started again, I'll go over the answers for you. All right. Now that you've had some time to check these out, let's go ahead and go over questions 10, 11, and 12. So it says here xy is the midsegment of the triangle. Great. So the two properties we learned about are true. I know that they're going to be parallel and half the distance. So xy. Okay, xy is half of the third side. So half of 17 will be 8.5. dx. So I see dx because xy is a midpoint, although it doesn't look congruent right here. If it's a midpoint, these two segments have to be equal to each other. And this is definitely not drawn to scale because this 6 right here looks shorter than this 4. So I know that I'm going to have to use the properties, not just going by what it looks like. So this is going to be 6 here. And I'm pretty sure I need this other piece here as well, which will be 4. So dx does equal 6, and yf does equal 4 on that one. Now I can move on to question 11. It says QR is the midsegment of the triangle. Find each measure. Okay, first let's solve for x. Okay, so common mistake of students right here is to just look at some things and set them equal. Looking at them, I know they're not equal. So what I do need to do is identify the relationship. I learned that a midsegment has a relationship to this third side right here. I know that the midsegment RQ is going to equal 1/2 of whatever that third side ZW is. Okay, so what is RQ? 2x minus 2.5 equals 1/2 of ZW, and ZW is 2x plus 7. From here, I can solve for x. I'm going to go ahead and instead of distributing this 1/2, I'm going to get rid of that fraction by multiplying both sides of the equation by 2. And when I multiply by 2 over here, all that happens is the 1/2 cancels out. So 2x plus 7. And that's a little trick you can use to get rid of fractions. Now I can distribute a 2 in here, so it'll be a little bit easier. And I also get rid of that decimal. So subtract 2x from both sides. Add 5 to both sides. And divide by 2, I get x equals 6 on this one. And just to make sure, I can plug it back in. 2 times 6 is 12, minus 2.5 is 9.5. And this should be twice as much. 2 times 6 is 12, plus 7 is 19. So sure enough, I do get that this is 19 and this is 9.5. That is half of there. Okay, so then WZ is, oh, well, that's what I was supposed to do, 19, and QR is 9.5, and they are. All right, number 12, let me get rid of some of the stuff I just wrote down here. All right, so for number 12, it says here we have a kite with a diagonal BD and AC. Looks nice, drawn to scale. BD is perpendicular, so the diagonals are perpendicular to each other, so BD is perpendicular to AC. Oh, these properties are pretty easy. Triangle ABC is reflected across to get triangle ADC. All right. Angle ABC, so angle ABC right there is congruent to angle ADC. So remember, this symbol represents the whole triangle. This symbol just represents the angle. Segment AB, so this segment AB right here is congruent to reflected across that line of symmetry, AD. This is real easy. And angle BAC, so BAC, this angle right here, is going to be reflected across and get DAC over here. So those two angles are congruent. So BAC, I guess it goes all the way, will be congruent to DAC. All right, so that does conclude our activity 15-1 over properties of kites and midsegments. There's a lot more properties of other quadrilaterals we're going to learn about. We started off with ones that weren't too hard. Once again, though, if you need some additional practice with maybe the midsegment is like question 11. Khan Academy. Triangle mid segments, perfect place to practice. All right, I'll see you guys next time.